stuff on here we'll talk about, go over chapter 1. If there's anything specific up here that you want more to talk about, let me know. A lot of the stuff up here has some stuff up in Canvas. Like I have a whole factoring handout. If you got to remember how to factor. Factor is stupid huge. Factor is stupid huge. Factoring is huge, right? So if you forgot how to factor, that's one of the things you want to focus on now. Trigonometry, at least as huge as factoring. So if you've got your trigonometry stuff, you're going to want to review that, yeah? And while I'm talking about it, I might as well show you here. You just get in my way. Go right. At least one person said they printed something out up here. Here's like trig laws, trig basics, factoring, quadratic equations, TI calculator. So here's all the laws that I'm going to assume you know. Everything above this black line is stuff you're supposed to know. If you don't, no, get into it. This is just like a basics. This should look very familiar. In fact, this might bring back some nightmares. I don't know. You guys ever have to complete a unit circle? I never make my students do that. It's one of the dumbest things. So why do I do that? Just to give it to you. Just so it's something familiar. Here's factoring, and there's a quick reference guide on the top. The number of terms tells you what type of factoring problem it might be. Quadratic equations, p to the square, all that kind of business. And then finally, how the hell to use your calculator. Oh shit, this is the wrong one. Well, this has some good shit on it, but I gotta put my other one up here. Okay, well, so let's come back to this. What do you think the hardest problem on here was? Anybody? What was anybody's hardest problem? Anybody? Were they all equally terrible? Is that what happened? Or were they all just a breeze? No, nobody. You're like, I can't pick one, Jeff. It's like my kids. Leave me alone. Okay, this very first problem, I gave one group a hint, something like this, and it said, "Do you remember how to simplify that?" Anybody remember how to simplify that?
Multiply by root 7.
Yeah, multiply by root 7. Why can't I do root 7? Because a square root needs two things in it, and it's only got 1 7. Yes? Now, it does have two numbers in it multiplied by 7. Is it a nice number? What number multiplied by itself is 7? Is that a nice number? Let me try this again. Let's do this. What number multiplied by itself is 9? What number multiplied by itself is 4? What number multiplied by itself is 7? There is one. Did you say 29? 49? No. What number multiplied by itself is 7? Okay. You all agree with me that it's between 2 and 3? You all agree with me it's not a pretty number? It's like 2.3149 forever, yes? Okay, I love you guys. I don't want to do square root of 7. I don't want to do it. Do you all agree that radicals are a little worse to work with than just whole numbers? 7 is much better than square root of 7 to work with, yes? So not only is radical 7 kind of gross, but it's also on the bottom. We don't want to have both of those things happening. So most often we'll do what's called rationalizing this. If you did trigonometry, you should have done a shit ton of rationalization, yes? So you guys go, no, well, shit, you should have. So what is rationalization? I give it what it needs. What do I need? I need one more 7 in there. And the only way to make that legal is to multiply the top by that also, yes? And then on the bottom it becomes what? Square root of 49, which is 7. That's half a 7 times half a 7 is a whole 7. Right? Square root is just half a 7 multiplicatively. So they give it another half a 7, it's a whole 7. What do you do? And on the top, whoo, that was hard. Okay. Can't multiply those in because they don't have the same root. Does that sound familiar? A little bit? Okay. So now what do you do, though, when the bottom's got more than just the radical? Well, you multiply by what's called the conjugate. And it's actually related to difference of squares. Come back to me. Thank you. So if I multiply by one group, I saw did this. Anybody else do this? What do you multiply by? Square root of x plus 1. So let's see what that does. On the top, I'm just going to leave this alone for now, and you'll see why. But on the bottom, what do I get? What's it? Radical x times radical x.
half of x times half of x is whole x, minus rad x plus rad x, the middle terms cancel, and then negative 1 times 1 is minus 1, and then what happens? Those cancel. Okay. So this is exactly the same as this. These expressions are exactly the same except for one value of x. What value of x are those expressions not the same for? 1, because 1 makes the first expression undefined and the second expression is completely cool. You guys kind of... Now listen, let's see if you guys remember this. If you were to graph this function, what would happen at x equals 1? What would there be?
Nope, right?
Hmm.
It would just stop.
There would be an open circle. Do you guys remember this? There would be an open circle there because there's no output for an input of 1, correct? But where would the open circle go? Where would it go? Well, what is the value of this at 1? What's the square root of 1 plus 1? 2. So it would be at 1, 2. There would be an open circle. I could use the simplified form of it to see where it wants to be. Why can't it be there? Because I'm not allowed to use 1. Does that make any sense? There's an open circle. How do I know where it is? Well, I look at the simplified version and see where it wants to be. Because these two are the same everywhere except at 1. Okay, I love you guys. You're all looking at me like I'm crazy. I'm used to it. What about this one? I have a really, well, I don't want to stand, a bad feeling about this one though. Understandably, students make mistakes with this all the damn time. This, with that said, does anyone feel comfortable telling me what they got? Yes.
Factor out a 2, or a 4, I mean, a 4, and so it's 4 times x squared plus 16, and then take the square root of the 4.
Okay. And you didn't do anything else?
No.
Did anybody else go further?
Well, like, I took the square root of 4, so it's 2 times the square root of x squared.
Sure.
And then,
All right. Did anyone get 2x squared plus 8? That's not good. Sorry. Thanks for letting me know. I know more than you guys did because I saw it. It's understandable. Real quick. What is the square root of 13 5? Is the square root of 13 equal to 5? If somebody thought that, what would you say? You would say, my God, what happened to you? Because square root of 13 is not 5. That's crazy, yes? Yes? But isn't the square root of 13, isn't it equal to square root of 4 plus 9? Yes? And then you could say square root of 4 is 2 and square root of 9 is 3, so square root of 13 is 5.
You can't break up the root if it's a plus.
Yay! What?
If it's a plus or a minus, you can't break up the
There
root.
it is. So what are radicals based on? What's another way to write the square root of x? X to the what power? 1/2 power. Because what's a radical do? Cut something in half multiplicatively, and what are exponents based on? Multiplication. So if I put a 1/2 in the power, that means 1/2 of this number multiplicative. I wish we had never made stupid square root notation. It is dumb. We have fractional powers. We wouldn't make this kind of dumb mistake. Because you guys already know, I can't take an exponent and go across addition subtraction. Why not? Because they're based on multiplication. Yes? If you wanted to do this problem, is that just x squared plus 4? Why is that not x squared plus 4? Because what do you have to do to it? What's something squared mean?
It's itself by itself.
Write it twice, yeah. And then you get a middle term, don't you? Yes? Why does it work that way? Because powers are based on multiplication. That's addition. They're not going to play well together. Yes? But if I had 2x squared, can I just distribute that shit all frickin' day long because powers are based on multiplication and that's what's happening. So they play well together. You guys with me? All right. There's going to be, how many of you guys are going to take Calc 2? Or is that in your plans? Okay. This is big in this class, but it's even bigger in the next class. This idea of simplifying radicals appropriately. Yes? Okay, so coming back to this, I completely agree with what whoever I was talking to earlier said. The only thing you can do with this is to factor out at 4. What's the square root of 4? 2. And what's the square root of x squared plus 16? I have no freaking idea. Done. It's kind of weird. We stop when we can't do anything else. That makes sense. That's a good place to stop. Is that okay? Be really careful about radicals. If you ever simplify a radical, just slow your roll down and say, did I just do something legal? Because if you didn't, everything else after that's going to be wrong. It's going to suck. Thankfully, you have a teacher that gives you partial credit. Real quick, any math teacher that requires a Scantron is not a math teacher. I don't know what they are, but what is the, I thought about wearing my other shirt that says show your work, but I thought it was a little bit harsh for the first day. I have a shirt that says show your work. That's the most important damn thing. If you make a mistake at the beginning of a problem, but everything you do after that is correct, you're only going to lose points at one time. So many of my teachers, if you do everything right and you did the last one wrong, the whole thing's wrong. I'm like, yeah, that seems fair. You guys all with me? So just show your work. Even if you think you're completely wrong, do what you think you should. Some of it might be right and you'll get more than nothing. Yes? What about this? This we talked about for a second earlier. What the shit do logs mean? What do they mean? What is that asking me? So let me. What is this asking me? What is besides it being a Rorschach test? Okay, what is that asking me? Cube root of 8. What's it asking me? What does it take 3 of to multiply to be 8? You have that in your head somewhere. If I say square root of 25, you sort of have it memorized that it's 5, but you know what that means. You have internalized what that symbol, what the sentence is. The sentence associated with any root is, what does it take this many of to multiply to be this? Yes? That's why the answer is 2, because it takes 3 2s to multiply 8, yes? So this is a whole big part of mathematics, is understanding it's a foreign language somebody in the past made up, and we are all having to catch up with it. We're like, what are these old white dudes, for the most part, what do they decide to do? And we have to figure out what the hell they were trying to do. That's a huge part of mathematics, is translating what the hell they're trying to tell us. Now, this is kind of nice because it's a symbol. What sucks is like trig and logarithms, they're words. That's extra trippy. But what does this asking me? This is asking me, what power does 3 need to become 27? That's what every log in the universe needs. What power does the base need to become what's inside? You guys with me? That's all that shit means, ever. Any log you ever see. What power does the base need to become the inside? Or you can even say, how many of the bases do I need to multiply to become the inside? So how many 3s do you need to multiply to make 27? 3. So the log base 327 is 3. How do you check yourself? 3 cubed is 27. So real quick, next question I want to ask. What's log base 8 of 2? It's not 3. Yes? 1/3. Beautiful. We just did cube root of 8, and it was 2. So what power does 8 need to become 2? It needs a 1/3 power. Right? Does that make sense? And then you cube root 8, which is a 1/3 power. Are you guys kind of with me? So if you know the question that the symbol represents, you have a way to attack the problem. Yes? It's not just memorization, it's translation. Oh. More with logs. Good Lord, Jeff. So I told one group that asked me about this. I said there was a property when I had the log of the product. In fact, it doesn't matter what the base is. Does anyone remember what that property is besides that one group I told already? Yes? Yeah, cool. So the log of a product is the sum of the logs. Now, real quick, why does that make nothing but sense? What was log base 3 of 27? It was 3. Why? 3 was the power. 3 needed to become 27, yes? The answer to a log is always a power. You guys remind me, when I have similar bases, what do I do when I multiply similar bases? What do I do, for example, when I multiply x squared times x cubed? Add them. That's what this says. What's the power when I multiply things with the same base? I add the powers. That's all the dumb thing says. Every property of logarithms is a property of powers because a log is a power. So mathematics, so many students look at math wrong. You're like, just show me the steps. No, the idea tells you what the steps are going to be. If you understand the idea behind something, you don't memorize barely anything. I don't have all the math I could do is not memorize. Thank God, because otherwise I would forget my name, where I live, I wouldn't have any room up here. Yes, I have a few basic things memorized, and I work off of those. Yes. So if you understand the idea behind something, you have to memorize a lot less. So how the shit do I do this? What's the difference then of two things? Let's just look at those two first. How do I rewrite? If the sum can be rewritten as the log of the product, a difference can be rewritten as the log of the So if this is true, what's log base b of a minus log base b of b? What do you think? The quotient, yes. I would have accepted the division of the two, because we don't remember the word quotient too much. So this would be log of x over 5x squared minus 5x, yes? Plus log 10x minus 10. This is another thing students don't do for themselves. You don't have to attack the whole problem at once. You can attack it in parts, yes? One big thing, is anyone really good at painting? Out of just curiosity, anybody paint or decent at painting? I don't want to make. Yes, you're decent at painting. Anybody decent at drawing? Drawing. Okay, there we go. Drawing. Okay. I'm not, and you might recognize by how horrible my handwriting is. I actually paint okay. I do a decent job painting. But drawing is stuff. I naturally break things up into parts. And that's one reason why I'm good at math. Not everybody does. When you draw, you naturally see the smaller shapes involved in what you're looking at. I don't see that shit. I don't. It's not there for me. Yes? You have to work on the idea of breaking a problem down. Does anyone see anything I could do just with this piece by itself? What can I do here? What can I do with the bottom, for example? Factor out more than that. What can you factor out? 5x. And what's left? X minus 1. Yes, everybody forgets that 1. Not everybody. And then these cancel, yes? Is that okay? Now what do I do with this guy? What's the log of something plus the log of something? What do I do with these things? Log of a plus log of b is log of a times b. So I'm going to do this times this. And then what's the last thing I could do with this problem then? Does everybody see that? A, b plus, so it becomes a log of a times b. 1 over this times this. Bam. What can I do on the top here? What can I do on the top? Factor 10 out. What am I left with? Minus 1, yeah. And what cancels?
The x minus 1.
And what reduces? So you get log
Log
2. Okay. Well, some people surprise me. They're like, I did all the work and they just got that. I'm like, I did all the work and I made that whole thing become that. That kicks ass. Okay. Let's do this. Okay. Alright, I kinda promised myself we would take a break about 11:30. Let's finish this up later. Do you guys, let's see. Yeah, I don't know, how do I feel it? Okay, if I say 15 or 20 minutes, you're gonna say 20 minutes, understand it. So you wanna take a 20-minute break? Yes, okay. So if you got some lunch, you can go eat it. If you don't, you can just go sit somewhere else. 20 minutes. Cool, alright. So then we'll all convene back here in 20 minutes, yes? Yeah. Yeah.
So for the last day is supposed to be July 17th. So my family plans on traveling to go see family from out of the country. So like as soon as like this class is over, we want to book like this same
So
year
this class will be
next year.
over on the 16th.
So it'll be over on the 16th, like right after like 1:25. Like we
Then you
finish
can
our final.
head out.
Okay,
Yeah.
sounds good. Because I want to book this month for the flight. So I was just making sure like the 17th we do not need to be here.
17th is out.
Okay,
Yeah.
sounds good. Thank you
You're
so
welcome.
much.
Hey, do you think I have time to go grab a calculator from the library? And
Yeah, you got 20 minutes. Yeah. As long as they're not crazy over there.
Is it okay if, will the TI-83 work for this class?
Any questions over stuff we just went over? Any lingering questions over the first few? Okay. And by the way, if we're doing some of these and you need a deeper dive, somebody already asked me if there's like, if I have logarithm worksheets and so forth, and I do. I've been teaching, alright, this is really tricky for me. I've been teaching for over half of my life. Do you understand? The moment I realized that, I was like, holy shit. I started teaching when I was 26 back in 98. And I looked like I was 17. And now I don't quite look that way anymore, but it's okay. I've been teaching over half my life. I've got worksheets. I've got handouts. I've got all of it. I put some of the stuff up in Canvas and I showed you that already, but if there's any specific things you're like, do you have a handout on that just email me or something, I can throw it up in Canvas so other people can have it. You guys with me? A little bit? Also, now that I'm thinking about it, did I remember hello. There we go. Okay. Sorry. Oh, here you go. I started collecting this a while back. Does any of that sound familiar to anybody? If you can see it. Professor Leonard is a big one. Organic chemistry tutor. Brian McLogan, Khan Academy, of course, with the hands and stuff. Professor V is new to me, but Nancy Pye is new to me. I don't know. People told me. I looked at these a while back. I didn't try to weed out anything because even if I thought it was bad, somebody else might like it. You know what I mean? So there's some things, and if you have one that you really love that's not up here, you can just let me know. I want this thing to grow over time. So there's a lot of holy shit. So very quick, old man story. Back in my day, walking uphill both ways and all that kind of stuff. We didn't even. I remember when the internet came out. You understand what I'm saying? You understand what I'm saying? You know, yeah, we get it, old man. So we didn't have. Holy shit! You guys have so much shit. You have so much. Now, so much of it is shit. You go to YouTube and you type in something, and you're gonna get a lot of shit. But you're gonna find somebody that you like that makes sense. You're gonna go to their channel and you're gonna see what else they got. Especially if you don't like to listen to me. Like, I don't want to go to his YouTube. I don't even like seeing him live. So you go to somebody else's YouTube and see if they explain it better. Yes? Okay. Sorry. Just while I was thinking about it, I want to show you that. Okay, so we left off here. And for the few people that asked me about that problem, the minute I showed them this question here, some of them kind of saw the connection. Do you guys remember how to factor this thing? Anybody? Yes? Yes. Kick ass. And it's really kind of deceptively simple. How many x's are there? 2. So there must have been an x and an x to make x squared. 25 is 5 times 5. And if you make the different signs, the middle terms cancel. And that's why you only get 2 terms at the end. That's called a difference of squares. I call it a thank your favorite deity problem, because I don't care how much shit there is, it's easy. If you can cut everything in half and it's a subtraction, it's doable. With that said, what would I do if it was x squared plus 25? What do you guys think? Huh?
Imaginary.
Oh man, you're after my own heart. First level answer would be that's not doable, which to some degree is correct, unless you open your door up to imaginary numbers, right? Better reference is lateral numbers, to be honest. But I'll show you a video later. Okay. You could say that's x plus 5i, x minus 5i. Because imaginary numbers are the only ones that when you square them, they can come out negative. No real number has a property, yes? Can you square a real number and have it come out negative? No, it's impossible. Okay. Which is why this is not factorable unless you use imaginary numbers. Now, forget about that guy for a minute. As long as it's a difference, is everything in this number, Jeff, is everything in that expression, can you cut it in half multiplicatively? Like 81 is, yes, so I can do that for everybody, yes? So let's do it. Bam, 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 bam. 9, 9. A4 is a squared, minus plus. 16 is 4, 4. W4 is W squared. Yay! Except, of course, I'm not done. Yes? Which one of those can you keep going with? Yeah, the one's got a minus, right? The 9a squared plus 4w squared. If I don't say factor using complex numbers, you don't need to. It's only reals, yes? We're going to be using real numbers for the most part in here. Imaginary will come in. So I can factor the first one. How do I factor the first two? Anybody? 3a minus 2w, 3a plus 2w. Spike, come on. Yes, maybe? Maybe? Does that sound familiar to anybody? Difference of squares? I don't care how much shit I throw into it. If I can cut everybody in half and it's a minus, it's easy. It's automatically has to be easy. Cut everybody in half, plus minus, next. Yes, what else you do? 2b understandably gave people trouble. But let me ask you this. Let me ask you this. Okay, Jeff. How do you factor this? Yeah. Yeah. Yeah, there's square. There. Yeah, okay. How would you factor this? What comes out? Look at the numbers. What comes out? 4. How many m's come out? 1. How many b's come out? 1. Yes? Yes? But what did I do? I just replaced 2m minus 5. Can anybody tell? What is 2m minus 5? What is it? The correct answer is, I don't freaking know, dude. Yes? Or some variation thereof. Yes? I don't know what the hell 2m minus 5 is. But what do you do in algebra when you don't know what something is? You call it x or b or whatever you want to. Yes? So if this works this way, this must also work that way. So, what can come out number-wise? 4. How many m's come out? How many m's come out? Somebody, okay, I love you guys. Somebody in the back is like telling me to steal first or something. Okay, so 1 m. And how many 2m minus 5's come out? Where's that finger? There it is, 1, yes. And then I say what's left. So if I look at each thing, I took a 4 out, it's gone. I took 1 m out, so what's left here? An m. I took 2m minus 5 out, one of them, and that only had one of them, so it's got none of them left. So that is what is left of the first term. So if I multiply this back in, of course, it becomes the first term. That's the whole idea. I am undistributed. That's what GCF is. So do the same thing with the next one. I took a 4 out, there was a 16, so now there's a 4. Bam. I took an m out, and there was only an m, and I took 1 2m minus 5 out, so there's 1 2m minus 5 left. Why am I not done? Can you simplify the inside? Yeah, you can distribute the negative 4, yeah, and then get your like terms together. Do you guys see that? So this kind of factoring is going to happen every now and again in here. There's one major idea in calculus. Well, let me say this. There's two major ideas in calculus, just two. We use the shit out of both of them, but there's only two main ideas. One is the opposite of the other one. Because anytime you learn an operation, don't you have to learn its opposite operation, the inverse, yes? So that's what calculus is, just two things. I'm kind of lying a little bit, but two major things. So this part looks good, looks clean. This part, I can distribute the negative 4. And then I can finally put my stuff together, yes? So if I needed to see where that equals 0, why is it so much easier now? If I needed to see where that expression equals 0, can somebody tell me one place that equals 0?
For n, like if n is 0.
If m is 0,
Yeah.
or if m is 5 halves, or if m is 20/7ths. 20/7ths. Okay. You guys at all? Yes? Maybe? No? Screw you, Jeff? Okay. So now we come to probably the thing that people love even more than factoring is trig. I saw a lot of people drawing little unit circles, which is kind of nifty. The way I remember a trig, cosine likes x, sine likes y. That gets you through everything. You don't need SOHCAHTOA. SOHCAHTOA sucks. If you like SOHCAHTOA, keep using it, that's fine. It just does so little for you. I wish we never taught it. If you remember cosine likes x, sine likes y. Does anyone remember what pi over 3 is?
60 degrees.
60 degrees, is that cool? Because what was pi? 180, so 180 divided by 360. You guys with me? If you have no idea what this shit pi over 3 meant, see me at some point. Yes? You have to know radians, you should know some trig stuff. If you feel like you're here and maybe you're like, I never saw trig in my entire life, we need to talk. Yes? Because that is not impossible that you got in here without ever having seen trig. It's not impossible. So ready with me. Don't freak out immediately, just come see. If cosine likes x, is 60 degrees closer to x or y? It's closer to y. Y would be 90 degrees, yes? So cosine should be small, because cosine likes x, not y. So that's why cosine of pi over 3 is 1/2. It's small. It's not rad 3 over 2, that would be pi over 6, that'd be 30 degrees, because it's closer. So I always think of it like a turtle. X is its home base. If it gets away, it starts to pull into its shell. Oh shit. Oh shit. Right? And by the time it's up here, it really don't like it. It heads all the way in its shell, yes? And very quickly, just a side note really, but it's a really interesting side note. What's the sine of 0 degrees then, if anybody was paying attention?
0.
Because sine likes y, this is nothing but x, so sine don't like it there, yes? What is the sine of 30 degrees?
1/2.
Good, it starts to build. Do you agree with me that the square root of 1 is still 1? Do you agree with me that the square root of 0 is still 0? Do you agree with me that when I divide by 2, I still get 0, yes? Okay, what's sine of 45 degrees? That's one that most people remember. You guys start to see a pattern happening. Rad 0 over 2, rad 1 over 2, rad 2 over 2. What should this be if the pattern continues? Rad 3 over 2, is that true? Yes, sine of 6 degrees is rad 3 over 2. And what about sine of 90? Continue the pattern.
1.
Continue the pattern. Rad 4 over 2, which is 2 over 2, which is 1. Okay. So that's a nifty, there's nothing more to it than it's just a nifty coincidence, but it is a nifty coincidence. I don't know if anybody's ever seen that before. But it is kind of nifty, yes? It kind of helps you. So if you know what sine does, sine grows, cosine shrinks as you go from 0 to 1 to pi. Yes? To pi over 2, 90 degrees. And of course, then you have to remember, if you remember sine likes y, cosine likes x, you know which quadrant, which one is negative in. Wherever x is negative, cosine is negative. Wherever y is negative, sine is negative. Because sine likes y, cosine likes x. SOHCAHTOA can suck it. SOHCAHTOA sucks. Just to remind you, if you like SOHCAHTOA, you can continue to use it, but it has very little usefulness. It's sort of like FOIL. Do you guys remember FOIL? You guys remember what it stands for? You know how much bullshit that is? Real quick, how would you do this then? How would you use FOIL for this? You need like a letter, like an M, so it'd have to be I don't know what that would be. I don't know if you guys are really with me or not. All FOIL is repeated distribution. I don't need FOIL. FOIL should not exist. Quick side note, when we make stuff like FOIL, we're telling students, oh, this is so hard. You need a little way to remember what to do. That's bad messaging, yes? It's not hard. You just repeatedly distribute. So when things get bigger, you just distribute more. You don't have to remember some FOIL thing. Okay, sorry. That's a whole side note. Let's see. So this would be 1/2. So what about this guy? What quadrant are we in? Yes, because you go back 180, and how much do I go past 180? 45. I don't know if that's what you said. Okay. I'm in quadrant 2. What's the SIGN of SIN? The sign of sine. In quadrant 2, what's sine? Positive, because it likes y, and y is positive in quadrant 2. 45-degree angle. Sine is root 2 over 2. Done. If it was cosine, it would have been negative root 2 over 2, because cosine is negative there, because x is negative in the second quadrant. Yes? Is this starting to come back? You guys cool? You guys all right? And again, if you feel like you've never talked about this before in your entire life, please come. All right. Now, understandably, this last one gave a lot of people trouble. Come back there. So let's talk about this on the back. Does anyone remember the definition of tangent? The really, really, really basic definition. Like if I have y, x, and then hypotenuse.
It's opposite over adjacent.
Sure.
Or it'd be
It's
side over
y
cosine.
over x. Yes. So it's a y side over the x side. You with me? Yeah, sine over cosine. Sine likes y, cosine likes x, so it's y over x. Is everybody with me? So this is going to be a really silly question. What do you put into trig functions? What do you put into them? Stuff. What is true about the stuff you put in? This is such a weird question. Give me a question that makes sense. Sine of, what's a question that makes sense? Sine of
Theta equals.
sine of theta. And what does theta represent?
Theta represents our like angle.
Angle. Good. So what do you put into trig functions? Angles. Yes? What are inverse functions? What are they?
We're putting in, instead of putting in the angle, we're putting in what it.
The answer, and we get an angle out. Beautifully said. So inverse functions take the x and y and switch them. So if I know how to put an angle into a trig, I get an angle out of an inverse trig. And here's why. Inverse trig, what will it do if I do inverse tangent to both sides? What do these two do?
They become one.
Well, they don't become one, they actually just cancel. So inverse tangent is the y side over the x side. This means the angle whose tangent is y over x, which would be this triangle, yes? So if you are ever given an inverse trig statement, you can immediately draw a triangle. So this angle is here. So where's 2? Knowing what you know about tangent, where's 2? The y side. And where's x? The x side. Do you guys see what I'm saying? You know tangent is y over x. So inverse tangent takes the ratio and says it's equal to the angle. So I can draw the triangle that's got that dumb angle in it that's got the sides correct. You can always draw a representative triangle for an inverse trig statement. Holy shit, Jeff. Okay. And the minute you draw that crazy rectangle, you can then answer any question they ask you about it. What do I need to figure out the cosecant?
The hypotenuse.
Yeah, how do I get the hypotenuse? How do I get the hypotenuse? Old Greek dude, right? Actually, his followers. By the way, he stole most of the work of his followers. It was a cult. So the followers did the work, and then Pythagoras took all their work, and that was his. Interesting math note. Doesn't really matter. No. So what is this hypotenuse again?
X squared plus 4.
Yes, square root of x squared plus 4. Because they equal c squared, and then square root, yeah. So what is the answer? What's the cosecant of this angle? What's cosecant? 1 over sine. Sine is y over hypotenuse, so cosecant is hypotenuse over the y piece. So this would be radical x squared plus 4 over 2. Choo! That was a lot, very quickly. But just to point out, and of course I did this to myself. Come here. You're fine. Chapter 1 is nothing but review. Yeah. Oh, let me do it this way. Donde está? Donde? There you are. Ways to represent a function, mathematical models. This has a lot of like graphs of things. This 1.3 is about translations of functions. 1.4 is obviously about exponential functions, and 1.5 inverse and logarithms, because logarithms are inverses of exponentials. Yes. So your first homework assignment comes from the review of chapter 1, and it's up on Canvas in case you don't have the book already. Yes? So I need you to jump into that stuff and come ready tomorrow with questions. Just to go over a couple things real quick. There we go. It starts off with, what is a function? Blah, blah, blah. Domains of functions, yes? In fact, here, real quick. Do you guys know how to find the domain of this guy?
Yes.
Non-negatives.
No?
Has to be greater than or equal to 0.
No? Well, what does?
X plus 2.
Ah, good. Whenever they say domain, they don't say anything about complex. It's understood to be real. So what are you allowed to put into a square root and have it stay real? What's the smallest number you can put into a square root? 0. So if you can say in English what has to happen, x plus 2 is inside of it, yes? So in English, the inside of any square root must be greater than or equal to 0. You guys agree with me? Inside must be at least 0. So if you can say in English what's supposed to happen, you can write what you just said in Mathish. How do you write? The inside has to be at least 0. How do you write that in Mathish? I don't speak Mathish, Jeff. Yes, you do. What's the inside?
X plus 2.
So the inside is x plus 2. At least is,
Greater than or equal to.
and then you solve it. Woo! There you go. X must be at least negative 2. And sure enough, if you check it, negative 2 plus 2 is 0, square root is 0, 0. So the negative 2 works. That's why I'm allowed to include it, yes? What about the second one there? Can somebody tell me in English what must happen for this to work?
Can't be 0.
Yeah, the bottom cannot be 0, yes? I need you to understand this. Any function that they give me, and they say, what's the domain of this function? They give me the function, they say, what's the domain? Just say in English, this must happen, or this cannot happen, and then write what you just said in Mathish, and then solve that shit, yes? That's it. So the bottom can't be Can't be 0. This is Jeffish, by the way. It's not English or Mathish, it's Jeffish. And so the bottom cannot be 0. How do you solve that? Factor, good, yes. I know what you're saying, but I just solved that inequality Directly. Factor in x out, and then what are the two things x can't be? What do you get when you factor in x out?
0. X minus 1.
So x can't be 0, x can't be 1. Do you understand? If I give you a function, not a graph of a function, because if I give you the graph, you can just kind of like follow it and see what the domain and the range are. Give you a function and say, what's the domain? English, what cannot happen or what must happen, then write what you just said in math. All right. I don't know how much more of this I want to talk about right now. I'm going to kind of rely on you guys to bring questions tomorrow. This is a really good page here, by the way. These are all the function shapes you should know. For me, this is page 32. What's really, really great about Cengage's books is, depending on the version you got, it's a different page. So good luck. Sorry, but you'll find a page right before 1-2 homework that's got this stuff in it. Blah 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 blah. Blah 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 blah. Let me see. Nothing interesting. So your homework actually comes from the review exercises, which for me is page 68. For you guys, I don't know. But it's basically the last thing in chapter 1 is the review, and then you go to the exercises, and that's where your first homework assignment comes from. You guys always do it. Okay. What's the first thing you do when you get a new math book? You look at the back, and you say, what do they have? Well, they have a lot of shit that I don't even know what it means. You look in the front, you see what look, they got a lot of quick reference, kind of like area stuff and so forth, and functions and trig functions. Yes? And you look to see what kind of answers do they give me. Oh, they give me the odd answers in the back. See that? So feel free to check your odd answers. And now you understand why I assigned some problems that were not odd. Okay. So let's get a little bit into chapter 2. Oh, this is beautiful. We got time. That was loud. What I like to do with chapter 2, I disagree with the order the book put it in. I like to do section 2.2 and 2.3 and then go back and do 2. And you're like, I have no basis I don't know if that's good. Just do it. Just do what you're gonna do. All right. Just to let you know, we're gonna start with 2.2, 2.3 and come back to 2.1. Here's a problem. Can you guys tell me, based on what we talked about before, can you guys tell me where this function might have an issue? At 1, correct? Can somebody tell me, if you plug a 1 in, what do you actually get? No, it's worse than that, to be honest. What do you actually exactly get?
0, 0.
On the top you get, no. On the top you get, plug a 1 in. What do you get on the top? 0, yes? Okay. So g of 1 is 1 squared minus 1 over 1 minus 1. You get 0 over 0. Now, real quick, just look at this. What is 0 divided by anything? 0 divided by 7, 0 divided by negative 3, 0 divided by 28. 0, correct? What is anything divided by 0? Undefined or infinite, correct? So what is 0 divided by 0? Somehow, both 0 and infinity and neither. Are you at all with me? Do you understand what I just said? I know you all are really clued in on the bottom being 0 is bad. That is so true. But if the top is also 0, that is a whole other level. That's a whole another level of that. Yes? Now, to be really honest, it's not bad. It's actually really good. But it's something we call indeterminate. This is not undefined. It's not defined. It's indeterminate. Good Lord, Jim. I swear to you. I don't know what it is. That's hieroglyphics. Okay. And we did something with this earlier. Can I simplify this? Can I simplify the top? Can I do something on the top? Yes, we can. Yeah. Whenever you have a fraction, what's one thing you look to do? See if you can reduce it. How do you reduce a fraction? Factor some of it and see if anything cancels, right? What cancels? So if I use this simplified version, where does g of x want to be at 1? It wants to be at 2, correct? You guys with me? Who has a calculator with them? Anybody? If you have a calculator, get it out. If you don't already have it out. Get it. I didn't bring my cooler calculator, so I'm sorry. So the rest of you guys just sit there and stare off into space. No. So I want to do a couple things. Let's see what the calculator says. I think it's just going to say, I'm really curious because I don't know if I've done this. Let's try 1 squared minus 1. What did I just do? Jeff, you have these things called glasses. Oh yeah. Divided by, parentheses, 1 minus 1. Let's see what it says. Ooh, all right, it just says divide by 0. Just to remind you guys, the calculator is really dumb. It is very dumb. But that's okay, you're trying. Okay. What instead, all right, I really want this to make natural sense. If we saw that shit, and we're like, okay, I know this doesn't go to infinity. Because you can plug, so how can I check this? Am I allowed to plug a 1 in? Do I get anything useful if I plug a 1 in? Do I get anything useful if I plug a 1 in? No, I get nothing, except for the fact that something weird is happening at 1. I don't get any information about what weird this is, correct? Okay, so you guys with me? Here's an example I like to give. Has anybody ever seen the movie The Blob? I'm talking about the 80s one, right? The 80s one we knew how to make movies. So at the beginning of the movie, if you've never seen it, this thing crashes to Earth. There's this guy, I think he's without a home. He's walking along, and he comes out, and if we saw that, what would we do? We'd probably go, "Ooh, well, that is weird. Okay, all right," and we walk away. What this guy did was, "Oh, that's weird," and then he touched the damn thing, and then it crawls up his arm and eats him, and the whole movie happens. With Are you with me? Hold on, you guys. You're all like, how does this apply to calculus? I don't know. Okay. If there's a spot on my graph where something weird happens, I don't want to go there. I can't go to 1 because weird things happen. Sorry. You're seeing the death of Jeff. Okay, sorry. Go back. So I can't go to 1 because weird things happen. So what am I going to do instead then? What would we do? We see something weird, but like, oh, what am I doing? Getting closer. But I'm not going to actually get there, am I? I'm not going to go there. Oh shit. That's bad. I've seen these movies. But we're going to get close and go, what is that thing? And we walk away because we're not silly. We're not in a horror movie. I don't think. So what do we do then? I want to then investigate g of 1. Investigate, Jeff? Sure. I'm going to investigate it by getting really close to 1. So let's do like g of 0.5. That's decently close to 1, yes? So that would be 0.5 squared minus 1 divided by 0.5 minus 1. Can you guys try to plug that in your calculator? Exactly like that. You got to be very careful. The calculator does not have eyeballs, thankfully. That would be weird if it did. I think the TI 3000 is going to have eyeballs, and then it's Skynet, and then we're all good. You have to put parentheses on the top, parentheses on the bottom. Yes. So already trying that out that has a calculator? What do you get? 1.5. Anybody else? Yeah, 1.5. Let me see. Let me do it too. Not that I don't trust you, but I don't trust you. 0.5 squared minus 1 divided by Jeff. 0.5 minus 1. 1.5. Cool. Now what do you think I'm going to do? Get closer, because 0.5 ain't that close. That's like, there it is, and I'm like, ooh, I'm going to get closer, yes. We're not going to be like the dude at the beginning of the movie. I'm not going to touch the damn thing. Because we already tried to, and we got weird shit. G of 0.9, let's say. Go ahead. See what you get for 0.9. Don't say anything. Just try it out. You don't have a calculator, don't worry. I'm not gonna look down upon you. You're okay. What'd you get? 1.9. Interesting. So what you guys got? Anybody else trying that out? 1.9? You could pretty much already make a, so what do you think we're gonna do now? 0.99. That's the last one I'll make you guys do, okay? You guys might be able to guess what you're gonna get. Somebody trying that out. What'd you get?
1.99.
Who knew? What does it seem to be approaching? 2, which is exactly what our work said it should do, yes? It seems to be approaching 2 when I plug a 1 in. To the simplified form, I get 2. Do I actually get 2 from the original function, though? No. But I see where it's going to. I see where it's approaching. Does it ever actually get there? Does it ever actually get to 2? No. So this is the idea of something called a limit. In the limit that x approaches 1, the outputs approach 2. And let me see if you guys are cognizant of something. Which side am I approaching 1 from? I'm approaching 1 from one side. From the left, yes? Aren't I approaching 1 from the left? 0.5, 0.9, 0.99, yes? I have to approach it from the other side also to make sure that it's actually going to that from both sides. So there's an idea of a limit from one side and an idea of the limit from the other side. And we see if they agree. You guys have seen piecewise functions, yes? And they do weird shit like this, where there's an open circle and a closed circle, yes? That would not have a limit there because the two sides don't agree. Does that concept make sense? It's kind of like me and my friend trying to meet somewhere. Did we meet somewhere? No, right? But we both go to this place and we're like, there's a freaking meteorite hit and there's a crater there. We can at least see each other. Hey, we're both the same place. We both had the same limit. We just can't go there because it's blown up. I'm sorry. I'm talking about blobs and meteors and stuff. All right. So if I did this from the other side, can somebody tell me a number I could plug in to investigate this from the other side? Not 2.01, because I'm not going to 2, am I? I'm going to 1. I understand why you said 2, because the output is going to be close to 2. But I want my inputs to get really close to 1. Is that cool? So 1.1. And not surprised now, you're going to get, I believe you should get 2.1. Yes. And if you keep going, you'll get closer and closer to 2. So everybody get the basic idea. So what I like to do, section 2.1 to me gets way too specific and in the weeds. 2.2 and 2.3 are just about the idea of limits, and then I like to go back to 2.1 because now the whole idea is going to make a little more sense. So I disagree with Stuart in this case. So let me give you a picture. This should be exciting. So let's say I have this kind of deal happening. Okay. What a beautiful function. Okay, so if you want to copy it down again. Let me ask you a couple of, in fact, let me introduce some notation. I should have introduced this back here, so this is my fault. Sorry for your notes. But I can say everything we just investigated here, I can sum it up like this. The limit as x goes to 1 of g of x is 2. That's what that says. So as my inputs approach 1, my outputs approach 2. Let me say that again. What that whole thing means is as my inputs approach 1, my outputs approach 2. Do my inputs ever get to 1? So a limit never gets to where it's going. Poor little dude. It just gets really close. And why does that make sense? Because weird shit's happening here, so I don't want to go there. Yes? Stop for a minute. So we get the idea. And depending on your teacher, when you did asymptotes, you guys remember vertical asymptotes, horizontal asymptotes? So your teacher could have introduced this notation or not, it's up to them. But basically horizontal asymptotes are the limit as x goes to infinity. So your teacher might have said something like, what happens when x gets really big? What's the graph doing? Does it have a ceiling it's going to? Yes. Is it going to 0? Do you guys remember all that? Sort of? Oblique asymptotes? So coming back to this. Let's say this is f of x. What is the limit as x goes to -1 of f of x? And by the way, this is a standard scale here. If I ever don't put a scale on, it's understood to be by ones. When you guys make graphs, please, dear God, make a scale and do blah, blah, blah. Okay. What is the limit as we get really close to -1? Yeah, you guys see that? Why is it really easy to see here? Somebody already put the open circle. Why did they put it there? Because they must have seen, oh yeah, the outputs are even really close to 1. So just to help you guys see this, as I approach it from, let me be more specific. So this is 1. As I approach it from the left, that's what this means. As I approach it from the left. So as my inputs, let me see, I really want you guys with me. As my inputs approach -1, so the input here, what's the output? There. Input here, what's the output? There. Input here, what's the output? There. As my inputs approach -1, my outputs approach 1. You guys see that? And of course I could say something for the other side. As my inputs approach -1 from the right, my outputs also approach 1. So we would say the limit exists here because those two limits agree. We both drove to the same sinkhole. Right, going back to my days in Florida. In Florida, the land doesn't go up, it goes down sometimes. In sinkholes. It was exciting there. Alligators and bugs the size of chihuahuas carrying small kids off. Florida. Sorry for Lake Florida. What's the limit as x? Oh, by the way, before I get too far, what is f of -1? Undefined. Kick ass. So the limit can exist, but the function value might be undefined there. Why is that not weird? Because limits never get to the input point. They just get close. Yes? You guys see that difference? This is huge. This is one of the first little hurdles to get over in calculus, is the difference between a function evaluated at a point and the limit of the function as we approach that point. So let me ask you this question. So this is undefined. What is f of 0?
3.
Yes! Sorry, I'll calm down. Yes. F of 0 is 3. Why do you say that? I see an open circle, but I also see a closed circle. So f of 0 is 3. It's defined. What is the limit as we approach 0 from Jeff? Not from Jeff. The limit as we approach 0 from the right.
1.
Do you guys see how to look at this graph? As I approach 0 from the right, as I approach 0 from the right, there's what a little plus means from the positives. As I approach 0 from the right, the outputs are approaching 1. They don't get there, but that's what they're approaching. And of course, what's the limit as I approach from the left? 3. So what's the limit as I go to 0? Period. Beautiful. Does not exist. Why doesn't it exist? Because we drove to 2 different holes. We're not even in the same spot. They don't agree. Yes? So if you guys were trying to decide on pizza, and I said, what if you decided on pizza? And each of you has a different, I want just pepperoni. I want only cheese. I want nothing but anchovies. What the shit? Right? I want lots of pineapple. You guys with me? And I say, what's your choice? Undefined. Does not exist. Because you haven't agreed. Yes? You with me? I wouldn't know what pizza to order. You haven't agreed on anything. Same thing here. If they don't agree, I just say it doesn't exist. There is no limit because they don't agree on what it should be. Okay. How you guys doing? Okay. I love you guys. I never want to play poker with most of you. No. What do you think the limit as x goes to 2 is? Yes. And it's not a bad idea when the answer is some kind of infinity to put the sign even if it's positive. Because that's going to be a huge part of the question is which kind of infinity is it? So we want to make really sure I see it's positive infinity or negative infinity, yes? Do you guys all agree with that? Yeah. I have a shirt that's got Gandalf standing there that says, "You shall not pass," because there's an asymptote. Sorry. Of course I do. Okay. How do you guys feel about this? So I would give you a graph, and I would hope, I'm hoping that you all see that this is relatively simple to see what these limits and these function values are. What is f of 2? What is f of 2? Huh? Undefined. Kick ass. Okay. I like it. Now, the next kind of problem we sort of already did. By the way, I got a little worksheet I'm going to let you guys work on here in a minute. If I wanted to investigate the limit as x goes to, I don't know. You can do it now. What did I do? I don't want to do the same function. I can't remember. We'll see. X goes to 3 of x cubed minus 27 over x minus 3. Sure. If I want to investigate that, I would do what we did earlier, except that'd be a little more organized. I can make an XY table. What kind of numbers do you think I'm going to plug in to investigate this? Yeah, I'm going to start like maybe 2.5, 2.9, 2.99. Is that cool? The reason I start at 2.5 is you got to give yourself enough so you can see the pattern. If you get there too quickly, you don't have enough numbers to see a pattern. Yes? So you want to kind of step back a bit and then come at it so you can see the pattern happening. On the other side, what's some numbers I want to plug in? 3.1, yeah. So I'm going to do, what I normally do is this. Like that. So I can kind of see it as I'm going this way and as I'm going that way. Does that make sense? So you guys help me out. Go ahead and figure it out. Go ahead and fill out that. Well, let's do this together. I'm going to make you do this yourself in a minute. But so let me show you something really cool. If you have your graphing calculator. Sorry if you don't. Oh shit, I'm in polar mode. If you put into y equals, if you put in here x cubed minus 27 divided by x, oh shit, x cubed, and of course now I forgot my parentheses, minus 27. Yeah, you gotta be careful when you do the, what do you call it? The exponent, you gotta come back down. Divided by x minus 3. Yes. You guys with me? This is something I don't know if everybody knows about. Y'all know your table, yes? Jeff. So normally when you do your table, it should look something maybe like, not like that. Like this. Yes? I have no idea what yours looks like. It depends on how you have it set. Do you guys see the problem at 3? The calculator just sort of gives up and it goes, okay. Should have that little weird ASCII thing. I don't know. Here's something really, really cool. If you go to table set, which is above window, you could change where it starts, you could change how big the steps are, but much more important is I can change the independent to ask. Independent variable being the x variable, because the y variable depends on the x variable, yes? So if I change this to ask, I could just build my own xy table. And actually I can make the calculator do it for me. So if you go to table, now it's empty. Thanks, Jeff. But now I can put in here 2.5, 2.9, 2.99, 3.01, 3.1, 3.5. See if I did all that right. Look at me go. Can you guys give me a guess as to what the limit is? As I get closer to 3 from both sides, do they seem to agree on what the outputs are doing? Where do they seem to be going? 27. Yes? You guys with me? So there's going to be a whole section in this homework that just has you making these tables. Ooh. But I really want you to go through this so that when we do limits later, you have the actual concrete, what the shit does it mean? It literally means this. I'm just getting actually close to the number. Now, you gotta be really careful because for some functions, that might not be close enough. You might have to go 2.999, 3.001. For some functions, depending on how weird they are or how unweird they are, you might have to go even closer. Okay. So it looks like the limit is 27. Does anyone have a clue how to show that algebraically? How can I show that algebraically? How did we do it earlier, just a little bit ago, when we had a ratio of polynomials?
Factor.
Most of you guys are looking at me like, we did? What are you talking about? Yeah, we factored this guy. Remember this guy? Okay. Does anyone remember how to factor x cubed minus 27? Or real quick, does everybody see that you can't freaking cancel an x? Yes? Why can't I do? Look, there's 3 of them. Why can't I kill one x?
Different terms.
Do it again.
They're in different terms.
Terms? How do you mean?
They're not put together by multiplication. They're put together
There
by
it is.
subtraction.
Division is not the opposite of subtraction. Kick ass. You guys with me? Because it's you're like, that's freaking 9, Jeff. I don't know what your problem is, math boy, but that is 9. No, it ain't. Because I'm not dividing 27. I'm dividing whatever the shit this is by whatever the shit that is. So I have to factor the top. Does anyone remember how to factor that with a cube? It's not a squares, it's a cubes. Difference of cubes, yes. Somehow I relate factoring difference of cubes. I relate it to the movie Pulp Fiction. Has anybody ever seen Pulp Fiction? Anybody? It's not a prerequisite for the class. You've never seen it. But you should see it. Because it's a really good movie. Even though it's really old. It's back when they knew how to make movies. I'll stop. I sound like a really old man. It's back when they knew how to make movies. The way you, real quick. Side note. How do I factor this again? X squared minus 9. 1x, because there's 2. 1, 3, 1, 3, because there's 2 3s. Plus minus or minus plus, right? Okay. So to factor x cubed minus 27, believe it or not, what I do is this. I'm going to make a little dude and a big dude, just to cut to the chase. The first step in a cubes is little dude, big dude. There's 3 x's, correct? And this is a little dude. So I'm going to put 1 x here and the other 2 there. Will I get x cubed when I start to multiply? Yes. I'm going to put 1, 3 here, because what's 27? 3 3 times 3 times 3, yes? So I'm gonna put 1 3 here, and the other 2 3s there. So do I get 27? Yes. I'm gonna make this the same sign as this. Now, why don't I just stop there? Jeff, why don't you just stop there? Why'd you make this big dude? What the hell's your problem? Because I get x cubed, correct? In fact, let's see. I get x cubed. I get minus 27. But I also get minus 3x squared. Do I want that?
Nope.
Nope. And I also get 9x. Do I want that? Nope. So, in Pulp Fiction, there's a scene. It's a scene where you start to question yourself when you laugh. So something horrible happens in the backseat of a car. And somebody later has to come and clean it. He's called the cleaner. I think his name is the Wolf. But he's the cleanup guy. He's the cleaner. So I call the middle dude and the big guy, I call him the cleaner. He cleans up the shit you don't want. And let me tell you, you didn't want that in the rest. So I need to put something here that will make these cancel. And what always works is, does this make sense? The opposite sign, well, it's supposed to be the guy that cancels shit, so it's got to be the opposite sign, correct? And then this times this. Let's see what we just picked up. What's x times 3x? Plus 3x squared. And what's x, I'm sorry, what is negative 3 times 3x? Negative 9x. Don't those die then? Don't I get exactly what I want? So people hate cubes because it's the one you have to directly memorize. The other ones you can kind of like attack. You can actually do something mathematical. This one feels like you have to memorize it, and you do. It's 1 of each, 2 of each, product in the middle. Yeah, 1 of each, 2 of each, product in the middle. There's another thing that I don't really like, but it's okay. This sign is always the same, this sign is always the opposite, and this sign is always positive. So since he's the cleanup dude, of course he needs some soap. Has anyone ever seen that before? Soap? You're all like, I've seen soap. No, but I mean in this context. Go take a shower. Okay, start down. No. Is that okay? Okay. Oh, I've got so much. So to do this algebraically now I know the top factors like this, and the bottom factors like this, and the bottom is that. So then these cancel. Can I plug a 3 in now? Is there any problem with me plugging a 3 in? Is there any issue? No, I've killed the issue, yes? So that's the idea of a lot of limits algebraically is, can you get rid of the issue? Can you get rid of the thing that is making it freak out? And here we did. We got rid of the thing making it freak out. If I plug a 3 in, what do I get? 3 squared is 9. 3 times 3 is 9. 9 is 9. What's 9 plus 9 plus 9? 27, which we already knew because we're awesome. We did that in the table, yes? We saw 27, didn't we? Maybe? Maybe? Okay. You're like, dude, this is the first day, man. I know. Done a lot. Okay. So I want to let you guys, let me see if I want to stop right now and let you do this. Yes, perfect. I want you to work on the front page of this. It's the one that says section 2223. It's got the red graph on it. There should be an extra one in there for the lady in the front. 1, 2, 3, 4, 5, 6. Look at me and count. Everybody got one? Or as long as you get one, yes, eventually. Go ahead and try this out here. I know we just talked about this notation, but see if you can use it correctly. So guys, I'm going to start to catch up to you. I think most of you guys are getting this. You're understandably, it's a really weird thing's got to click in your brain about how to track what's going on. And I see it happening with a lot of you guys. And I'm like, this is really trippy. You've never quite looked at a graph like this. So when I tell you, I specifically want the limit as I go from the left. You can literally go to the left of Jeff. Don't go to the left of Jeff. Go to the left of -4. Pick an input, see where its output is. Get closer, see where its output is. Get closer, see where its output is. Where do they seem to be marching? 2. Yeah. And then from the right, exactly the same thing. Pick an X, see where its output is. Pick an X, see where its output is. And they seem to be approaching 2. Does everybody see that? I'm trying to be more careful. I used to say from above and from below, but that really tripped people out. I always think from above and from below, but people think this, of course, which makes sense. So I'm trying to say left and right. So what's the limit as X goes to -4? Straight up, part C. 2, because they agree. Yeah? It's kind of like me saying, okay, one group went here, the other group went here. Where did everybody go? They went there. Or really close to there, I should say. And what's f of -4? Undefined, kick ass. So I said this to one group, but this is a very important thing to say. The limits do not give the first shit what's actually happening at the point. So the limit doesn't care what's happening at -4. It just cares what happens when you get really close. F of -4 doesn't give a shit what's happening anywhere except right at -4. Do you understand what I'm saying? So those two are completely unrelated. By the way, real quick, how would you describe the behavior of the graph here? Like it's going up, and then what's it do here? Well, how do you describe this behavior? It's going up, and then what's it do? It does what? Can you imagine a little dude running? What did he do? He's running, right? Somehow he doesn't exist for a moment, and then he keeps going. And then what's he do? Falls or jumps. Yeah, that's actually called a jump discontinuity. So I'm just throwing that out early because that's exactly, you guys can see that's a jump. The function jumped. Yes? This has got its own name. Should be pothole discontinuity, but it isn't. We'll talk about that later. Okay. So as I approach 1 from the left, if I pick an X value and I see where its outputs are and I get closer and closer, I see the outputs are approaching 4. And if I remember correctly, I think most people got that. Sorry, I might have been off the screen there. As I go from the right, I pick an input and I look at where its output is and I get closer and they get closer and they seem to be approaching -2. Is that cool? So what is the limit as X goes to 1? Does not exist. You can just put D and E. But what is f of 1? 4. It's totally defined. It's defined to be 4. There's no ambiguity there. That's where the output is. Is that clear? Okay. And then the last guy is this last bit. As X goes to 6 from below, what's the limit? 5. From above, it's also 5. Is that cool? So what's the limit? I love you guys. I gotta look up for you guys because some of you guys are mouthing it. Like, okay, so what is f of 6? 2. So f of 6 doesn't give a shit what the function looks to be doing. It could not exist. It could be undefined. It could be somewhere else. By the way, I just can't stop myself, but this kind of discontinuity, this kind of thing, we call it a removable discontinuity. So if you had a sinkhole in the middle of a road, can I use that road? Could I remove the problem? Yes, I could fill it in, right? I could fill that hole in, you with me? So if I just defined f of -4 to be 2, I would fill that circle in, there would be no discontinuity. Are you with me? I can just keep going on the road. I don't have to stop. It's about teleport to the other side. This one, this is like somebody tried to fill in the pothole, but they missed. You're driving down the road, you know, go through the pothole, and you see this big pile of freaking asphalt, and you're like, what? They were close, I guess, right? So we call this a removable discontinuity, because if I defined the function value correctly, I could remove the open hole, I could fill it in. Okay. Did anyone get to this yet? What is natural log of 1, by the way?
0.
Good, and what's x1 minus 1? So what form is that in when I try to plug a 1 in? Indeterminate. Okay. That's going to be huge. Knowing that something is in an indeterminate form is going to come in and out of this class the whole semester. It's going to be a recurring kind of thing. Every now and again, it's just going to pop up and go, oh yeah, it's indeterminate. So if you build this in your calculator, and if you don't have a calculator, I'm very sorry. You have to put parentheses so it knows what's where. If you have yourself set to ask, when you go to your table, I can just overwrite this business, 0.9, 0.99, 0.999, 1.01, 1.1. I could do 1.5, sure. Just because I wanted to. So what's the limit seem to be? As you approach 1? Yeah, the limit seems to be 1. Maybe I could do 0.9999 just to make sure. Because you see how that's sort of a big gap, but it's a nice pattern approaching 1. Could I use algebra to simplify this? Look at my face. If you could, teach me. Because can I factor natural log of x? No. Once we learn a little calculus, we'll actually revisit this, and there's a really nice way to do this quick and prove that the limit really is 1. Right now, we just have to go off the feels. It feels like it's 1. Do you agree the limit could actually be 1.000000006? Yeah, we're just looking, it looks like it's 1. That's the best we could do. We're just human. Okay, maybe. But you could put in here like 1.9999, Jim. 0.9999, and the calculator's just like 1, dude. So it's a pretty good guess. Okay. I love it, guys. So what's the limit? 1. We can see that from the pattern in the table. Yes? Just to point this out, the first 3 on the back, I saw a few people were looking at this one. Like part A, you should be able to do relatively easy, yes? What would I do here? Factor. Look at part B. Let's talk about part B. And then I'll consider letting this out a little early. Let's see how this goes. Look at part B. Does anyone have, real quick though, what you should always do when they give you a limit problem is make sure there's a problem with the input I'm talking about. What happens when you plug a 0 in? Is there a problem there? Yes. Why? Not only is the bottom 0, top is also 0. Now, real quick, if the bottom was 0 and the top wasn't, that is not a problem. I know the answer. Let me do 2 things on the side just to increase the amount of time you're here. Too bad. If I ask you what's the limit as x goes to 3 of -1 over x minus 3 squared, is that indeterminate? Is that in indeterminate form? No. Because what's the only thing that's 0? The bottom. And what happens when the bottom gets closer to 0? What's the whole thing do? When I'm dividing by smaller and smaller, my outputs are getting bigger and bigger. Yes? So this is -1 over something going to 0. It's getting bigger and bigger and bigger. So this is actually negative infinity. Do you agree with me that the bottom is always positive as I go to 3? I don't care which side because it's squared, correct? So the bottom is positive tiny and the top is negative. So this will be negative infinity. 1 divided by 100, 1 divided by 1,000, 1 divided by 10 billion. Sorry, I'm going the wrong way. 1 divided by 0.1, 1 divided by 0.01. That's getting bigger and bigger, correct? -1 divided by 0.01, -1 divided by 0.001. That's getting bigger and negative. So that would be negative infinity. Okay, I want to make sure you understand the difference between bottom of 0 and indeterminate. Indeterminate means I cannot determine the answer yet. That's why I love that word. It's indeterminate, I can't determine the answer yet. If it's not indeterminate, I have to be able to determine the answer. So that is not indeterminate, I can determine the answer, I did. Yay. Okay, maybe. Maybe, Jeff. What was the other thing you wanted to do, Jeff? I forgot. So just keep going. Do you remember what we did earlier when it had a radical? Multiplied by the conjugate. What would the conjugate be in this problem? 3 plus rad x plus 9. Good. This is on the other side of the paper, by the way, if you didn't turn your paper over. Try to multiply top and bottom by 3 plus rad x plus 9. Do not foil the bottom. Trust me. Oh yeah, I remember what the other thing was. Now the top gets a little funky, and you have to be really careful. There's a mistake people make with the negative that's going to come up over and over again. It's going to get you every time. How do you simplify the top? Does everybody agree with me that the middle terms cancel? Do you see that? Like 3 times 3 is 9. That's amazing, Jeff. Plus 3 rad x plus 9 minus 3 rad x. You see the middle terms cancel, yes? But then what do I get at the end? Minus what? X plus 9. But if I do this, what have I done wrong? I'm supposed to subtract that thing, yes? I'm supposed to subtract x plus 9, not just a piece of x plus 9. That's an easy mistake to make. You guys see that? That completely changes the problem. It goes from possible to impossible. So it's really 9 minus x minus 9. So the 9s cancel. On the top I get negative x, over the bottom I get 2x times 3 plus rad x plus 9. And what happens, that's really nice. What's the one thing that I can do now? Cancel the x. Why is that nice? Because that was the whole reason I could not plug a 0 in. Once I kill the x's, I can plug a 0 in now. It's not indeterminate anymore. It's -1 over something. So what do we get? We get -1 over twice 3 plus, plug in a 0, 3, -1, 12. That's what I get. And just to show you something, this is related to this problem, so I'm not exactly lying when I said I'll let you out. Jeff. Just to show you real quick. 3 minus square root x plus 9 parentheses divided by, oh shit, I'm still in the parentheses. Go away. There you go. Oh, I need parentheses. Okay, divided by, where'd it go? 2x. If I graph this, oh man. Oh, interesting, Jeff. Stay with me. Look at that. It's great. if I try to, yeah, of course the outputs are really small, so let me do this one little thing for us. I'm gonna make this go from -1 to 1, so I can see a little bit better what's going on. There we go. Now watch. Do you guys know about this? If I hit second calc value, I can make the calculator calculate some. For example, if I put in here 2, it'll tell me the output is -point blah 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 blah. If I try to put in here calculate value at 3, let's see what it says. Was it 3? No, 0. If I try to put 0 in, what's the calculator do? Something very interesting. What's it do? What's the answer? Y equals, and again, it should have that little dude going like, I don't know, right? No? Okay, so that's how the calculator tells you there's an open circle there. Where would the open circle be? 1/12, I think we got, right? The limit was 1/12? -1/12, thank you. And sure enough, doesn't it look like it's down negative, yes? All right, okay, let's stop. Yeah, I'll let us out a little early. What are we supposed to go to 1:25, I think? Yeah, we can go 10 minutes early, it's fine. We've done a lot. So we haven't talked about 2-1 yet. So when you start the homework, definitely do chapter 1. Come with questions tomorrow. Try to start 2-2. Yeah? Get a little ahead when you can. If you don't have a book and you want copies, scans of like chapter 2 homework, let me know. Okay. We'll do it all again tomorrow. If anybody has unfinished business with me, come on up here.